Welcome to Module 203A on Principles of Automatic Heating and Cooling Circuits. We're going to look at different requirements of a basic heating cooling system, and we're going to discuss how to achieve and keep comfort levels. We are going to be covering 4 different objectives inside this module, and we're going to start with the requirements of a basic heating and cooling system. The idea of having a heating and cooling system is to create a controlled environment where you can feel comfortable. So we're going to start with talking about the concept of heat. Heat is created by having energy in transit, so it's produced by the movement of molecules. The more movement we have, the more heat we have, such as rubbing your hands together to create friction. Heat always moves from an area of higher temperature to an area of lower temperature, and it will continue to do so until both areas have the same temperature level. The process of transferring the energy from the warmer object to the cooler object is what we call heating. And the greater the temperature difference between two objects, the faster that energy transfer happens. So if you think about your house, on a cold winter day, your house cools off very quickly because your house is trying to heat the outside. Heat can be distributed in 3 different ways. The first way is called convection. Convection is a process that happens within any fluids, such as air or water. What happens is that as warm air or water rises, it leaves room at the bottom for the cool air to settle. And then once that warms up, that starts to rise and it creates a circulating current. And that current itself is what is distributing the heat. The next method is called conduction, which is transferring heat through solid objects. So if we heat one portion, it increases the molecular movement inside that section. That increased movement spreads to the adjoining molecules all the way along. And as that molecule movement spreads, so does the heat. The further away we get from that heating point, however, we are dissipating energy into the air in form of heat. Therefore, we have less energy to spread to other molecules. And the further away we get from our heating point, the lower the temperature is going to be. The third method is called radiation, which is heat transferred by electromagnetic wave motion. You can think of infrared heaters or sunlight or fires, or even if you're sitting near something cold, your body is radiating your heat to that cold object. Typically, the heat is commonly created by either an electric current going through an element or by burning a combustible gas or a solid. Now that we're familiar with the idea of heat, let's discuss cold. Cold can be described as the relative lack of heat, and we can't say that something is cold without comparing it to something else. And what is cold and what is warm is all a matter of perspective. For example, if we had a 0-degree day in August, we would say that that is a very cold day. However, if we had the exact same 0-degree day in January, we'd say that that is very warm. So it's all a matter of perspective. Since heat is the transfer of energy, we can measure this, and there's 2 different standards that we use to do so. First of all, we have our SI units, which is what we would see in electrical, energy being joules and power being watts. However, we also have imperial units. Imperial units include BTUs and BTUHs. A BTU stands for a British Thermal Unit. In this case, it is how much energy it takes to raise 1 pound of water by 1 degree Fahrenheit. And 1 BTU is equal to about 250 calories or 1055 joules. Power is BTUH, which has a time component. So how many BTUs we have and how long of a duration are we using that heating for. Electrical heating is typically rated in watts. We find that gas appliances, such as our furnaces, are typically rated in BTUH. Heating systems are rated according to the rate of energy input for the appliance. In this case, 75,000 BTUH. When we talk about system efficiency, we are comparing the input to the output. So it talks about how much power is being put into the appliance compared to how much usable heat comes out of the appliance. In order to calculate my efficiency, I want to compare my output to my input. In this case, my output is 60,000 and my input is 75,000. So if I divide those 2 numbers, this particular unit will have an 80% efficiency rating. You will also notice that the elevation has an effect on the power ratings as well. If we go above 2,000 feet above sea level, we'll notice that our power ratings for both our input and our output will be lower. This is mainly because we have less oxygen at higher elevations, so therefore the gas would run leaner. When it comes to measuring cooling, we also have 2 different ways we can do this. The SI unit is ton cal per hour, and the imperial system unit is the ton. An average house is about 7.5 ton cal per hours, which would translate to 2.5 ton unit. Since the purpose of installing a heating and cooling system is to create a comfortable level for people, we have to discuss what comfort is. The human body creates its own amount of heat, but if our body loses heat too fast, that's when we feel cold. And if our body keeps too much heat so we don't shed enough heat quickly enough, that's when we feel hot. The ability of our body to shed heat depends on 4 different variables. First, we have to consider temperature. A room temperature of about 20 degrees is considered to be comfortable for most people. That means that the heat transfer from our body does not happen at too quickly a pace. Remember, the greater the temperature difference, the faster that heat transfer is going to happen. So the closer that the temperature of the room is to our own bodies would mean that we slow down that rate of energy transfer. The second thing we need to consider is humidity. Humidity in the air affects the evaporation from the body. If we have rapid evaporation, we feel cold. Think about getting out of a pool and standing in the wind. That's rapid evaporation because you feel that chill. And the higher the humidity prevents that evaporation from happening and we start to sweat. 40% humidity at about 20 degrees Celsius is comfortable for most people. The higher the humidity in your house, however, can also affect things like door jambs and hardwood floors, so we need to be careful about how high the humidity gets. The third factor that's going to affect things is the amount of air movement. Air movement also affects the evaporation rate. The more the air moves, the cooler we feel because we have more evaporation from our skin. The air movement will also remove any heat and moisture, and this is considered to be one process of convection. Lastly, radiation of heat will make a difference. The radiation of heat from the body to colder objects, such as cold walls or exterior walls. If you're sitting too close to a window or too close to an exterior wall or concrete floor, your body is going to radiate your heat to that colder object, which is also going to make you feel uncomfortable. So you want to make sure that we avoid that radiation of heat as well. All 4 of these variables must be in balance for us to feel comfortable. And if any of them are out, then it creates a condition known as cold 20. An example of this would be if the temperature was set to 20 degrees, but the humidity was really low or a fan was on, we could still feel cold even though the temperature is set correctly. In order to keep us inside our comfort zone, we usually employ automated controls. The main reason for automated controls is not only for comfort, but also for convenience, safety, and economy. They create a self-monitoring system that allows us to change the temperature and the humidity inside the house and keep it at a balanced level for our comfort. And we can use controllers such as thermostats and humidistats to do so. We also use automated controls for safety and to prevent dangerous conditions. A high limit switch's job is to make sure that we shut down the burners in case the temperature inside the furnace itself got too high. Whenever we have an automated system, such as a thermostat and a furnace, it creates what's called a closed-loop control. Any automated system such as this works on the adjustable thermostat presets. It is self-monitoring due to a temperature sensor inside the thermostat that provides constant feedback. Our loop control starts with our room feeling comfortable, and after a while, our comfortable room starts to cool off a little bit. When it's cooled enough to hit the temperature preset on the lower end, the thermostat contacts are going to close. When they close, that turns on the gas valve, which will ignite the burner. Now, by this time, our room has gone past the temperature preset and is starting to feel a little bit cold. The next thing that happens is as the burner ignites, it warms up the plenum, which will close the fan switch and start the blower. This is how we integrate the warm air back into our room, and our room starts to feel warm again. Once our room temperature nears the thermostat preset, the thermostat contacts open, our room is now comfortable, and we are back into our beginning. Once the thermostat contacts open, a number of things happen after that that we are not typically aware of. The gas valve will close, the burner will stop, the plenum cools off, the fan switch opens, and then the blower stops. All this is happening while the room is starting to cool off again after we've reached that comfortable level. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.